Okay, now let's move on to the next subtopic, dividing polynomial. There are two ways to dividing polynomial. There are two ways to divide any polynomial function. So the first method is by using long division and the second method by using synthetic division. So let's look at to the first method, long division. So this is the simple example. So let's say we have 77. We try to divide by 3. So when we try to solve this one, so you will get here 2 times 3 is equivalent to 6 minus between these two values, and then we have to move 7 down. So 7 minus 6, so you will get 1. So this one will become 17, and you will get 5 multiplied by 3, so you will get 15 minus between two values, so you will get the remainder is equivalent to 2. So we can rewrite this one as a 25 2 over 3, or we can also rewrite as 25 plus 2 over 3. So in the values of 2 here, we call it as a remainder. 25, the values of 25 here, we call it as a quotient. And the values of 3 here, we call it as a divisor or dx. So in general, for the polynomial function divided with another polynomial function, it is equivalent to the quotient. So for this case, this one is our quotient. And then plus with the remainder divided by divisor. So we can rewrite this one as a remainder Rx, which is 2 divided by the divisor. So this is algorithm of polynomial. And then when we try to rearrange these two, when we try to multiply both sided by dx, so let's say this one multiply by dx, so multiply by dx, so what left is just bx, and then qx times with the dx, so you will get qx times dx here, and then rx over dx times with the dx, so you will just get rx. So you can also rewrite algorithm of polynomial in form of px equals to qx multiplied with the dx plus with the rx. So let's look at to the example 1. Divide the polynomials px by dx using a long division. Give the final answer in the form of division algorithm. So let's say for this case, how can we apply division algorithm or in terms of long division? So the first step, we have to write down the px to x squared minus x minus 3 divided by, our divisor given here is x minus 3. So how can we get the values of 2x squared? So our aim here first is to remove the first term in polynomial, which is 2x squared. So in order for you to solve, so you have to first step remove the terms 2x squared. And our divisor here is x. So how can we get 2x squared when we try to divide with x? So up here we should have the values of 2x. Why? Because 2x, when you times with the x minus 3, so you will get 2x squared minus 6x. So we will put the values here in your method here. So we will get 2x squared and then minus 6x. Or in other words, 2x, you have to times x, and you also have to times with negative 3. So when we try to put in this form, so you will get actually 2x squared minus 6x. And the operation here, of course, should be minus. So divided by, now it's already removed. So the term, no more term of x squared. So 2x squared minus 2x squared, 0. And then negative x, you minus with the minus 6x. So you will get here is positive 5x. So we will get here positive 5x. And then we have to move negative 3 down. So you will get minus 3. And the next aim is to remove the terms of 5x. So how can we remove 5x when we have x here? So we can put up here as a positive 5. So when we try to multiply between 5 and x minus 3, so what you will get is 5x minus 15. So we will bring this in our method here. So 5x minus 15. Or as I mentioned earlier, you can just 5x times 5 times x, so you will get 5x. 5 times x, so you will put 5x here, and 5 you also have to times with negative 3, so we will put under the coefficient of negative 3. So you have to make sure try to when you try to minus between the values, the degree of x must be equal. For example, 2x squared, you have to make sure it must be put under 2x, under x squared. And let's say for this case, 5x, so the terms of x, you have to make sure the terms below must be also in terms of x. Then you can minus between both terms. So minus all together, so you will get the remainder here is equivalent to 12. So when we try to rewrite in terms of division algorithm, so our px, when you divide with any divisor, so you will get equivalent to, so this is our quotient, this is our remainder, and of course this one is our divisor. So we can rewrite in terms of algorithm as quotient 2x plus 5 plus with the remainder 12 over with the divisor x minus 3. So this is what we call as a division algorithm. So let's look at to the next question. So in this example, they ask you to divide between this polynomial and determine the quotient and remainder. So in this case, the question doesn't ask you to write down in terms of algorithm. So what the question asks you to do is just to take out what is qx and what is rx when you try to divide polynomial, the px by dx. Okay, so before you proceed, I want you to try out A, B, C. So before that, for the first question here, x cubed plus x squared minus 4x plus 3. So there is no missing term because the degree of polynomial is already in order. Power of 3, power of 2, power of 1, and then we have a constant. But when we look at to the question part B, we have 5x power of 4, and we don't have the term with the x cubed. And then we have 17x squared, 19x, and we have 6. So what you have to do when you try to divide for the part B, you have to put the missing term as 0. So for the missing term x cubed, you have to put 0 plus 17x squared minus 19x plus 6, and then divided by quadratic term, which is x squared minus 2x plus 1. Why you have to put 0x cubed? Because when you try to multiply between this divisor, so there is a possibility for you to get the term of x cubed. So as I mentioned earlier, when you try to minus between two values of x, you have to make sure the degree of x must be equal. So when you try to multiply, when you get the term in terms of x cubed, so that's why you have to put it under x cubed, so that when you minus, so you can minus 0 minus with whatever values that you get here. And then for the part C, also we have a missing term, so we have to put it as 3x power 4 plus 0x cubed plus 0x squared plus 2x plus 9 divided by x plus 1. So you have to put 0x cubed and 0x squared. So you have to put, otherwise you try to minus between different degree of x. Okay, so I want you to proceed example 2, A, B, C. So we'll discuss in class. Now let's move on to the synthetic division. So another method to divide any polynomial function is by using synthetic division. But synthetic division can only apply when we have the divisor in terms of x minus c. So for example, just now when you try to divide, let's say we refer to the previous example. A is the previous example. When you are using long division, 2x squared minus x minus 3, when you divide by divisor x minus 3, so you will get here 2 and then 2x, so 2x cubed, 2x squared, and then minus with the 6x, then minus, so you will get here 5x minus 3, And then this one should be plus 5x. This one is previous example. So this one you will get remainder as 12. So this is our remainder and this is our quotient based on the previous example and by using long division. Okay, so in synthetic division, when you can only apply for the x minus c, meaning that your divisor must be linear. So in polynomial function, let's say for the long division, when you have 2x plus 5, when your divisor is linear, your remainder must be constant. And then let's look at to the previous example here. So when your divisor is quadratic, your remainder in general must be linear. And then for this one, our divisor is x plus 1, which is linear. Your divisor must be, let's say, just a constant c. So the remainder must be reduced by the power of 1 as compared to the degree of your divisor. So that's why when your divisor is x squared, so remainder should be linear. So let's look at to this one. So that's why when you try to divide for the synthetic, the condition here, the divisor must be in terms of linear. So when the divisor in terms of linear, your divisor, your remainder will be in terms of constant. For example, x minus 3. So you will stop. You cannot proceed anymore with the long division because your remainder is already reduced by the degree of 1 as compared to the degree of your divisor. So 12 is a constant. So let's say we have x minus 3 here. So what is the values of our c? So c here is equivalent to 3. And then we have x plus 2. So actually it is x minus 2. So our c here is equivalent to negative 2. And then for this case, our c is equivalent to half. So in general, the divisor must be in terms of x minus c. So c will be our divisor. So how can we apply the synthetic division? So let's look at to this example. So we will use the same example here. So the first question, part A. So when you try to apply synthetic division for the question part A, so let's look at to this one. Our c just now here is equivalent to 3. So x minus 6. So our c is 3. And then we will put the coefficient of each degree of x. So we have the highest is x squared. The next one is x. The next one is 0x. And we need to put the coefficient. So the coefficient of x squared is 2. Coefficient of x is negative 1. Coefficient of 0x is negative 3. So this is how the synthetic division looks like. So the operation here will be plus. So the first step, we have to bring the first coefficient down. So you will get here equivalent to 2. And then 2, we have to times with the values of c first. So 2 times 3 is equivalent to 6. So we will put 6 next to the coefficient. So which is in this case coefficient of under x. And then we have to plus between negative 1 plus 6. So you will get the values is equivalent to 5. And then again, we have to repeat the same step. 5 times with the 3. So you will get equivalent to 15. And the operation here, negative 3 plus 15. So you will get the remainder here is equivalent to 12. So the values at the back here is referred to the values of the remainder, and the first two term or the values next to our remainder is 2 and 5. So that is the coefficient of our quotient. So we will start with the 0x and then x. Or in other words, it will reduce by the degree of 1 as compared to the degree of polynomial. So if our polynomial function here is x squared, so we will start the coefficient of quotient with the x. So here our quotient is equivalent to 2x plus 5, and then our remainder is equivalent to 12. So if you try to compare with the previous method by using long division. So we get the same values or the same term for the quotient and also for the Rx. So of course, as compared to the long division and by using synthetic, so synthetic is the easiest method. So because we just have to put the constant, but the restriction here is we can only apply when the divisor in terms of x minus c. So when your divisor is quadratic like the previous example, for example BC, you can apply synthetic division. So synthetic when your divisor is only in terms of x minus c ataupun in terms of linear. So for example, for the question P, for the question part C, you can apply synthetic because the divisor is x plus 1. Okay, I want you to proceed with the question B and C. So discuss during class. Okay, that's all for 3.1 and 3.2.